our focus today is on transformations in the plane, and we are going to discuss the transformations as reflections, rotations, and translations. And we will have a little bit more details on these, but reflections are nothing more than a flip. If you flip a shape, it is a reflection. And of course, a rotation would be a spin. A translation is a slide. And so we will bounce back and forth between the formal vocabulary of reflection, rotation, translation, and the informal flip, spin, and slide. One of our objectives is to be able to just look at pictures and say, oh, that's what it is. That's one that got flipped. And be able to describe that flip, or that spin, or describe that slide. Additionally, if we are given something that says we want you to rotate this 90 degrees clockwise, be able to do that. If you have a starting value and you are told do this thing to it, we want you to be able to graph that. And thus we'll note our vocabulary: transformation, reflection, rotation, and translation. A transformation is any kind of movement. We already saw reflections are flips, rotations are spins, translations are slides. These other two you might not be familiar with. Pre-image and image are vocabulary that you certainly need to know. We will use them consistently whenever we talk about transformations. Quite simply, they're just the beginning and ending values. Where do you begin? That would be called the pre-image. Then you do the transformation, and it takes it to its ending location, which is called the image. That's it. And of course, we don't expect you to have all these pieces written down, but the Alhambra is a palace in Spain, and it's fairly famous for the geometric patterns that they use for part of the architecture, and just, well, it's not wallpaper and it's not exactly painting, but using tiles, the place is just covered all over the place, and they really like to use repeating geometric patterns, and so it's kind of famous because of just how cool it looks. We do have some pictures that are similar to the Alhambra within this video. If you'd like, we can pull up some Chrome after the video, and we'll actually find some pictures that people have taken on vacation there or something. Now, as I mentioned, a transformation is basically just any kind of movement, any kind of change. Pre-image is the beginning location, image is the ending location. One part that we need to get used to describing is how that movement is written down. And we use an arrow and prime notation to do that. For instance, if we take a point A and it gets moved, we'd use an arrow to say that it got moved. Then it gets moved to A prime. In this image, in this notation, we have our pre-image, followed by the transformation that does the moving, and it gets moved to the image location, which we indicate with a prime. If something got moved twice, we would use a double prime. If it got moved 3 times, we would use a triple prime. That way we can stack one movement into a sequence, one followed by the next. For instance, here's what we could look at. We would have the triangle pre-image ABC on the left getting moved to A prime, B prime, C prime. And we're just describing how it all comes together. You see the notation with the primes? That's all we're looking at doing right now. Just emphasizing a little bit more in case you're a person who wants to have a quick picture drawn. A reflection is a flip. And so here's an example for how things look when you flip them. A rotation is a spin. And so here's an example of how things could look when you spin them. A translation is a slide. Several things that are relevant that will help you identify. You notice how this piece right here, that is called the axis of reflection. It's the line that you flip across. Every time you do a reflection, no matter what you're reflecting, we will reflect across 90-degree angles. If you can recognize that 90 degree, that might help you identify it's a reflection. Rotations are always spun around a point. It's called the center of the rotation. And any kind of a gap, you'll notice that we've got this piece drawn in and we have the tick marks telling us those are congruent lengths. Things don't get spaced out differently when you spin a shape. And the slide is the simplest one where you just slide it across your desk and that's it. Thus, what is this thing? Is this a reflection, a rotation, or a translation?
Rotation.
I've had one person say rotation. What makes you think it's a rotation? Because it is a rotation. I like that answer. When we're looking at pieces, we can identify the order of the points. You see how we have, and I want to use a different color here. How we had A, B, C that went clockwise. The order of the points getting named goes clockwise. In the image, A goes to B, goes to C. That order is still being named clockwise. A reflection would flip that around. If we reflected it, the order would flip from clockwise to counterclockwise. And so this absolutely is, I'm writing a T there, it's a rotation. And now we need to describe it with arrow notation. Triangle ABC got rotated to triangle A prime, B prime, C prime. And we're done. What about this one? Reflection, rotation, translation. Well, pay attention to the order of the points. D went to E, went to F, went to G. That's a clockwise order of the points. D, E, F, G. That's counterclockwise. The order of the points has changed. Its direction, anyway. That tells us it has to be a reflection. The only way you can switch around the order of the points is with a reflection. And I did hear a couple of students say, oh, that's just a translation. Looking at it where we can just slide it downward. You've got to be careful because if we were to take just the rectangle, and let me use a fill color on this one. If we were to simply take the rectangle, we could slide the rectangle downward and match up the shape. That would be a translation. But if we did that kind of a translation, we have to keep in mind that D would have been moved to D prime, E would have been slid down to E prime, F prime, and G prime. But that is not where the points got labeled. It's not only about having the shapes fall on top of each other. We have to make sure the correct points are moved on top of each other also. That's exactly why we have this prime notation to help us identify things. What about these two? For problem A, is this a reflection, rotation, or translation? Translation. We can see MP and MP along the tops, M prime and P prime. And so we would have M, N, O, P, got moved to M, N, O, P with each of our primes. What about the one on the right? Okay. A rotation that moved triangle X, Y, Z over to triangle X, Y, Z with our primes. And we're done. Of course, our work yesterday was based in the coordinate plane. So can transformations. So consider this. A figure has vertices A, B, C. After some kind of a transformation, it's been moved to A prime, B prime, C prime. What is it? Right, so we just have to start with our directions. Draw the pre-image and the image. This is one where a sketch can be problematic, and so you do want to use more accurate drawings if you can. I, of course, suggest doing this stuff with real graph paper. That way all the gaps and everything are preserved. You don't have things getting changed in size. And so we could look then at 1, -1 for point A, 2, 3 for point B, and 4, -2 for point C. Okay, we have that drawn. Then we need to draw -1, -1 for A prime, -2, 3 for B prime, and -4, -2 for C prime. We drew the pre-image in blue and the image in red. What kind of transformation is this? It is a reflection. And we're done. If you want it to be a little bit more precise, you could tell that we're actually flipping this across the middle here. Simply calling it a reflection is acceptable for what we need, because we do come back to this topic and build on it later. But we could refer to it even more detailed as a reflection across the y-axis, because we're flipping it across that middle, across the y-axis. Now, one of the pieces that we will, of course, work with, we'd like to be able to describe these transformations using coordinates. And this arrow notation can be expressed even further this way. And admittedly, there are rules for how you would do a reflection. There are rules for translations. There are rules for rotations. Our focus today is only with translations for this. And when we come back to the topic later, we do hit up reflections and rotations with more detail down the road. But right now, we're starting only with translations. A translation can be described just with addition and subtraction. And so when we look at this, we can see x plus 2. Well, remember that x is left and right. So what is a plus 2 going to do? We recognize that we're sliding the shape right 2 units. Additionally, what is y minus 1 going to do? We know the y-coordinate is up and down. So what would minus 1 do to up and down? It'll be down 1. Just by looking at the arrow notation here, using these coordinates, we can now draw where the image is going to be just by counting out, going right 2 and down 1. So starting with my point A, we'd have to go right 2 and down 1, moving us toward there. Now, of course, you're typically just going to count them out, but I'm trying to show the video. For B, we'd go right 2 and down 1, putting us right there. and not drawing it in this time, just counting 1, 2 on C, down 1, we've got C prime. And there we've drawn our translation, based on nothing more than looking at the notation and knowing what it's telling us to do. And these are pieces that we can get through very quickly. What is this one going to do? That's left 2. What is that going to do? So quickly counting through, 1, 2, 1, 2, 3, 4. There's our point J. For point M, 1, 2, 1, 2, 3, 4. There's point M. For J prime and M prime. When you do a translation, it does not change the shape of the object at all. I wouldn't even need to go through and do any other kind of counting, because I could bring this piece here and simply recognize that since it was too wide at the bottom, I could go too wide and finish drawing off my rectangle, because it's got to stay the same shape. Too wide stays too wide. 8 tall would stay 8 tall, or 7 tall would stay 7 tall. 3 wide stays 3 wide. They don't change the lengths. Now here's one where we are working backward. Instead of having the rule, we want you to describe it. So we are moving from hexagon 1 over to hexagon 2. How did we do it? Well, it's definitely a translation. But how did we translate it over? How far to the left and how far up? Perhaps the easiest way of doing that is to find one set of points that got moved together. A got moved to A prime. So we had to go left and up. How far left was it? Simply counting 1, 2, 3. Then we also went up. How far? 1 1/2. So there's 1 1/2. We're done. We have our rule written out. All right, so write a rule. To go from square 1 over to square 3, what do you have to do? Well, from square 1, we know we will have to go down, and we will have to go left, matching up point A with point A prime. How far to the left? How far down? Well, we'll count our tick marks. 1, 1, 2, 3, 4. That's down. 1, 2, 3, 4 left. And we're done.